All right, welcome back, everybody. Who knows what day it is? I don't know what day it is. We're getting to the end of the semester, right? Our math 335. We got a question brought to us from section 3.4. And I think the only way to really go about doing this is, well, no, I can write them down first. Says, which one of these is the graph? It's a little too bright. And that went dark really quick, one click. Is the graph for y equals x cubed minus 5x squared minus 28x plus 32. Okay, so and there's a bunch of different graphs. Maybe I should put question 1. A does some shit like this. There's a wiggle like that. B has some shit like this. C has some shit like this. And D has, let me zoom in on this bad boy. Actually, you can barely even see that shit. It's doing some shit like this. It's comes down and barely goes over the line and barely goes above the line and barely goes over the line and barely goes. But this is really hard to see, this above and below the line, even magnifying it on that. So which one could it be? Well, important things to note. This is our leading term. So the leading term defines how end behavior looks. And it comes in 2 categories. The exponent is odd, and if the exponent is even. For the odd exponent, and it also depends, like, we have ax to the n, so the exponent here is n, of course. The next part depends on a. If a is greater than 0, odd exponents do stuff like this. On the left side, it goes down. On the right side, it goes up. If a is less than 0, it's the other way. It goes up on the left side and down on the right side. For even exponents, we have the same information. A greater than 0 makes them both put their hands in the air like they're a true player. And if a is less than 0, they put their hands down. There's also one more piece of useful information. N here says that there can be at most n minus 1 turning points. Like going up and then down is a turn. Going down and then up is a turn. So for our problem, we've got x cubed, n equals 3. A is 1, it's unlisted, which means our end behavior should look like this. N equals 3 tells us there's at most 3 minus 1, which is 2 turning points. Now, the first piece of information was all we needed, because there's only one of them that is doing this. Right? But just in case they threw some more shit in there, like if it was going up and down, up on the left and down on the right, B and D both go up on the left, down on the right, and then we got to count like number of like turns. And so like if A was negative, D would still be out because there's just too many turns here. Here, there's only 2 turns. But A is positive, so it's going to be C on that one. C, final answer. What you got next? So this question, that question was brought to you from 3.4. Also brought to us from 3.4. So this is 3.4. It says 3.4.53 at the very top of the thing. It says use the intermediate value theorem. For polynomials to determine if the polynomial function has a real zero between, it says the number is given, but then it just gives the number. So I don't need to say it. Between 2.7 and 4.3. The polynomial in question is x to the 4th plus x cubed minus 6x squared minus 26x minus 13. So the idea behind the polynomial theorem is this. And we're looking at 2.7 and 4.3. The IVT is its shorthand name. It says that if one value, the function value is negative, like let's say f of 2.7 is negative and f of 4.3 is positive, it has to cross somewhere in the middle. It could be the other way around. It could be up top. F of 2.7 is up here, f of 4.3 is down below here. Somewhere it's got to cross. It doesn't say where it crosses, it just says it crosses between these two. So this is busy work for your calculator. Calculate f of 2.7 and f of 4.3. I'm going to let you do this because I don't want to do it. Maybe I will, but I'm not gonna say the answers until you have your answers. So what did you get for F of 2.7? Got -54. But they're both negative though. Would you get for 4? I might have done something wrong too. One of us did, apparently though. If you have it on your computer, it should have the old work. You can always check to see if you did it wrong. Parent 185. So F of 2.7, it's the green line right here. Or blue now that I wrote over it. Somewhere it must cross. So yes, this polynomial has a real zero between 2.7 and 4.3. Make sense? Like the name really isn't important here, as long as you understand the idea. If one of the values ends up being negative and the other value ends up being positive, somewhere between them it's got to equal 0, because it's a connected line. The line's got to cross 0 somewhere. It can't just teleport over. Oh, there we go. Next question. Nope, this is the same question. Question 3.5, 3.5. Let's take a look at this bad boy. So this is 3.5, and at the top it says 0.17. This is question number 8 for our student. It says explain how the graph of f of x equals 11 over x can be obtained from the graph of y equals 1 over x. Then graph f And then do domain range. So if I have 1 over x and I want to turn it into 11 over x, how could I do that? And it gives us a couple options. It says shrink or stretch. That's a terrible way to put those words. This might help. Make a little table. Maybe just do the positive numbers. 1, 2, 3. If I put in 1, I've got 1 over 1, so y equals 1 here. If I put in 1 here, y equals 11. So right out the gate, y equals 1 is here. Y equals 11 is way the fuck up here. Then we do 2. Y equals 2. Nope, 1/2. We stick into 2, we get 1 over 2 is 1/2. We stick in 2 here, we get 11 over 2, which is 5.5. So here at 2, y equals 1 over x is like that. That's like 1/2 and then 1. But 5.5 is half the distance to the goal. It's way up here. So the graph of y equals 1 over x, if you memorize how it looks, and you're supposed to, it looks like this. It looks like this is doing it too. But instead of going up 1, it's gone up 11 right here. So this has gone, and this went from 1/2 to 11 over 2. How could I go from 1 to 11? There's only 2 ways. Just basic math operations. Don't picture the graph, just think. How could I go from 1 to 11? You could add 10 to it. Add 10 would get you from 1 to 11. What else could we do to get from 1 to 11? We could multiply it. We'd have to multiply it by 11. So 1 would get us to 11. Now that's what we did on 1. What would work on 2? I want to go from 1/2. It's got to be the same thing as well. I want to go from 1/2 to 11 over 2. Only one of these operations will work. Which one? If I add, I go from 0.5 to 10.5. It's got to be multiplied, right? Add didn't work. If I multiply this by 11 over 1, basically. 11 times 1 on top, 1 times 2 on bottom. So it's multiplying, so it's making it grow. Each of these has grown by multiplying by 11. Or grown by a factor of 11. Factor is a multiply term. And so if we look at it, the options we're given for this, it's going to do a factor of 11 right there. That's what's going on. It looks like it went up. Horizontally would be left and right. This looks like it goes up. So it went up vertically. And there is no way I would call that shrinking. Shrinking would be getting smaller. So stretch is the only other choice there. It's a terrible word to use. It's misleading, but that's what they chose to use, shrink and stretch. Then they gave us a couple graphs to look at. Fuck. One of them, only A and B have the right shape. Okay, so let's see, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 lines going upwards and it says 16. So each of these is 2. So like the first line going to the right is going to be 2. And we know it should be 5.5. Because we just did it right here. We got 2 and 5.5. So we want to see on which one the first line goes up almost 3 boxes. This one looks like it goes up 1, 2.5. That looks right. This one, when we go over 1, it's only going up a little tiny bit. So it's not going up enough. So B doesn't go up enough, A does. This looks like A is the correct answer. And finally, what is the domain here? Do we have any restrictions on what X cannot be or what X can be? Is there anything I can stick into 11 over X that's going to break the system? The graph actually helps. But like anything I can stick into 11 over X that's going to make this bad. Like what, is there anything, any value of X that will break this? What? 1 doesn't work. We already know 1 works because we plugged it in, we got 11. Things that will break it make the bottom 0, or they make what's inside the square root negative. Can we stick anything in that will make the bottom 0 here? Zero breaks it. In fact, we can see that where X equals 0, this vertical line, the y-axis, the line is like going away from each other. It's not trying to connect. So if we want to write 0, X cannot equal 0. So in interval notation, that's negative infinity to 0 in union with 0 to infinity. Oddly enough, if you look at the graph, the range has the same problem. The y value, it never actually hits the x-axis. So y can't equal 0 either. Which makes sense if we look at 11 over x. And we try to say, what can we plug in that will make 11 over x equal 0? Nothing. Nothing will make that true. So we can't plug anything in, so the range is also going to be that. Did I have it over and was I writing on this thing and not showing you a damn thing? Should have said something. Got another one? All right, this is an interesting question. This says. This is 3.5.107. Says find a possible equation. For a function. With a graph with the following features. We have x-intercepts are -3 and 3. Well, -3, 0 and 3, 0. The y-intercept is 0, -9. We have a vertical asymptote at x equals 1. And a horizontal asymptote at y equals 1. Okay. So first things first. X-intercept is when, or the y-intercept is when x is 0. Oh, let's So maybe we should start with the x-intercept. The x-intercept is when y equals 0 or f of x equals 0. So this is like if we factored this, we got x equals -3 and x equals +3. Now, if I move everything back to one side, like add 3 to both sides, I get x plus 3 equals 0. And if I subtract 3 here, I get x minus 3 equals 0. And then I could like kind of unfactor these and make this x plus 3 times x minus 3 equals 0. Because when it can be either one of these, then both of them multiplied together are going to equal 0. So this should be like the numerator. The numerator should have this in it. The vertical asymptote tells us what's on bottom. It tells us where we have a vertical asymptote where the bottom equals 0. And so if x equals 1, then we subtract 1 from both sides, we get x minus 1 equals 0. The bottom must have this, so the denominator must have x minus 1. So we're getting there. Let's build what we got so far. I got x minus 3 and x plus 3 up here. And I got x minus 1 down here. Now, the y-intercept, let's see what happens with the y-intercept. Y-intercept is when x is 0. So if I do f of 0 with what I have right here, I have -3 times +3 over -1. I get +9. And the y-intercept is -9. Which means I'm off by a negative sign. Right? I'm off by a negative sign. Which means we need another way to introduce a negative sign. Now, it might just be put a negative out front. But there's one more piece of information we haven't looked at. We haven't looked at the horizontal asymptote either. So the horizontal asymptote, when we have a horizontal asymptote, it has the same degree on top and bottom. And right now, I have 2 x's on top. So the top is x squared right now. The bottom is just x. Which means I need to add another x on bottom. I need to have another way to add another x on bottom. So x minus what? Well, we only have one vertical asymptote. Which means I can't have a different value down below. So maybe x minus 1 would work. That way I don't have an extra vertical asymptote that's unaccounted for. I still have the same vertical asymptotes. Does this fix my y-intercept problem? Does that fix the y-intercept problem? Let's take a look. If I do f of 0 now, I have 0 minus 3 times 0 plus 3, 0 minus 1 times 0 minus 1. The top is -3 times 3. The bottom is -1 times -1. These two negatives cancel out. I actually end up with -9 now. That did fix our y-intercept at the same time. So an f of x that would work, that has all of those criteria, would be x minus 3 times x plus 3. And they probably have this written as x minus 1 squared. And they do. Got another one you want to do, or? What? Hasn't come through yet. That's all? Good. Any questions from you, Eric?
No, no, right now.
All right, let's pause that. Starting for 10 minutes from another topic seems lame. Let's take a look at what we're doing today.